Hey there guys, in this video we're going to take a look at a Russian Math Olympiad problem in which we want to find the largest x for which this expression, this number, would be a perfect square. But before we go on, consider subscribing and ring the bell to not miss my latest videos, and hit the like button if you find this video helpful. So first of all, let's say that our number is equal to u. So we want to find the largest x for which u is a perfect square. Now, finding an x for which u would be a perfect square is straightforward, it's not complex, but finding the largest x for which u is a perfect square is a little bit tricky. So bear with me till the end of the video to not miss anything interesting. Now, u is equal to 4 to the power of 27 plus 4 to the power of 1000 plus 4 to the power of x. So we want to find an x for which u is a perfect square. So first of all, let's replace 4 with 2 squared. So we will have u equals 2 to the power of 54 plus 2 to the power of 2000 plus 2 to the power of 2x. Now let's go ahead and factor out 2 to the power of 54 because 2 to the power of 54 is a perfect square. So u equals 2 to the power of 54 times 1 plus 2 to the power of 1946 plus 2 to the power of 2x minus 54. Now notice that 2 to the power of 54 can be written as 2 to the power of 27 and then squared. Therefore, 2 to the power of 54 is a perfect square. So if we want u to be a perfect square, we need to find an x for which this expression is a perfect square. And for this to be a perfect square, it has to be in the form of 1 plus 2a plus a squared, because this is equal to a plus 1 all squared. So in that way, this is going to be 2a, and this is going to be a squared, right? So let's say that's the case. In that way, 2a is going to be 2 to the power of 1946, and a squared is going to be 2 to the power of 2x minus 2x minus 54. From this, I can say that a is equal to 2 to the power of 1945. And if I square both sides, I get a squared is equal to 2 to the power of 2 times 1945. Now, since a squared is equal to a squared, I can say that 2 to the power of 2x minus 54 is equal to 2 to the power of 2 times 1945. From this, I can say that 2x minus 54 is equal to 2 times 1945. And now, since everything is divisible by 2, let's go ahead and divide everything by 2 to get x minus 27 is equal to 1945. And from this, I can see that x is equal to 1972. So we know that if x equals 1972, u is going to be a perfect square. But the thing is, we don't know if x equals 1972 is the largest x that we can find. So let's go ahead and assume that x is larger than 1972. And then let's go ahead and try to find a way to prove that there is no x beyond 1972 that will make u a perfect square. Now, notice that u is equal to 2 to the power of 54 times 1 plus 2 to the power of 1946 plus 2 to the power of 2x minus 54. So for the sake of simplicity, let's go ahead and say that this is v. Now, notice that inside of we have 2 to the power of 1946, and that is really important. So in order to have 1946, I'm going to subtract 26 from both sides to get x minus 26 is larger than 1946. Now from this, I can say that 2 to the power of x minus 26 is larger than 2 to the power of 1946. Now, I can go ahead and say that 1 plus 2 to the power of 2x minus 54, and then plus 2 to the power of x minus 26 is larger than 1 plus 2 to the power of 2x minus 54 plus 2 to the power of 1946. Now, if we compare the right-hand side to u, we can say that this is equal to v, right? And the left-hand side can be written as 1 plus 2 to the power of x minus 27, and then squared, plus 2 times 2 to the power of x minus 27. And the right-hand side is v. Now, based on the square of a sum identity, I can say that the left-hand side is 1 plus 2 to the power of x minus 27 all squared, and this is greater than v. And from the definition of v, we can say that v is greater than 2 to the power of 2x minus 54, right? And this can be expressed as 2 to the power of x minus 27, and then everything squared. Now, notice that this number and this number are two consecutive numbers. So, v lies between the squares of two consecutive numbers. Therefore, v cannot be a perfect square. Now, if v cannot be a perfect square, then u cannot be a perfect square as well. And this happens when x is larger than 1972. So, in other words, we can say that when x is greater than 1972, there is no x for which u is a perfect square. Therefore, x equals 1972 is the largest solution for which u is going to be a perfect square. And this brings us to the end of this video. Thank you for watching this video. Hit the like button, leave a comment, and subscribe for more. Hopefully, I will see you later. Goodbye for now.